Well, you know what? So Scarab isn't actually an acronym.
Okay.
We designed the robot and we designed the body in its shape for a number of reasons, largely to ensure that we had ground clearance at different postures, so it has that sort of boat hull shape in the bottom. The front and back are sized for the particular payload, and then rather than have sharp corners and make it out of aluminum, we used a thin layer of carbon fiber. Those curves actually give it a lot of strength. So it came out, the design process resulted in this shape, and then we looked at it and said, well, that looks a lot like a beetle. We put that paint job on it and we called it Scarab. So no acronym.
No acronym. What exactly is the Scarab vehicle used for?
So Scarab would precede astronauts and enter into these polar craters to determine whether there are resources there that the astronauts could use.
So how is Scarab actually going to be able to maneuver and work in the dark or in the shadows of the crater?
We can't use cameras in the dark. We use laser scanners, so the robot's able to navigate on its own. It uses those scanners to model the terrain, decide how to avoid obstacles or how to climb through things in order to get to the next location it's trying to reach. And it would travel very slowly through this area using very low power, drilling samples, processing them through the instrument payload to measure the abundance of the hydrogen and oxygen. Then it would slowly move on to the next place, probably spending 6 months or more to survey one of these crater floors.
Well, speaking of power, I understand the Scarab runs off of very low power. Well, it will be able to run off of very low power on the moon.
Here on Earth, we have about 600 watts to work with. We have 6 times the gravity here. On the moon, we're designed to operate with only 100 watts, so about the power of 1 light bulb. And that's in large part why Scarab is a slow-moving vehicle. The drilling operation proceeds very slowly because you just don't have a lot of power to work with. We're working with Glenn Research Center to reference the Stirling engine that they've been developing. This is a radioisotope source that produces about 120 watts continuous for 10 years. So we put a thing the size of a microwave oven in the back of Scarab, and it's gassed up and ready to go for 10 years.
Technology used to analyze these samples is already aboard the Scarab?
So that technology is being developed at Kennedy Space Center in conjunction with Johnson Space Center, along with the drill that's being developed in Canada. Canadian Space Agency is working on that. And then we'll be doing a test not just of mobility as we're seeing here, but also the process of the samples, processing of this regolith simulant, operation of the instrument payload.